All right, let's finish up the lesson from chapter 10, section 2. The previous uh, video was just about simplifying, but there's some other operations we can do with it as well. So let me just start with an example. 2 radical 7t. So we've got square root with a number and a variable times 3 radical 14t squared. Let me grab a little eraser here and get rid of some extra there. All right, so the principle of this is you have to go ahead and multiply the numbers, but no problem when dealing with radicals is ever done until you've got it simplified. In fact, you'll have some rules in that a little bit later. But let's just start with regular numbers. We're going to take the regular numbers. We're going to take the regular numbers and just multiply the 2 and the 3 there. So those 2 is going to be 2 times 3, which is 6. Not difficult at all. The other rule is that all radical numbers can be multiplied, divided, or combined together just like regular numbers. They just have to stay in a radical. So 14 times 7. 10 times 7 is 70. 4 times 7 is 28. So that should be 98. And then you've got t times t squared. Remember back from chapter 7, you add exponents of variables when you're multiplying them. So we end up getting 6 radical 98 t cubed. Okay, that's great. Not too hard, hopefully, for everybody, but now we have to simplify. So we've got to look for perfect squares. The 6 we'll leave alone for a second, and the perfect square that's a multiple of 98 is 49 times 2. So that's still 98, but it's in a way that shows me the perfect square. And then t cubed we also have to take care of. All right, so what is the square root of 49, It's 7. So we're going to pull that outside. Remember that you do 7 times 6, which is 42. Can't do anything with that 2, but we need to take care of that t cubed. Remember, with variables, we switch rules. Now we're going to take that 3 and divide by 2. The 3 on the exponent right there is what I'm talking about. 3 divided by 2 is 1.5. Well, that means I can pull out 1t, but the half means 1t has to stay inside. And so 1t comes outside, square root of 2t. And that is a fully simplified problem when also multiplying. Let's do one more to give you a little bit more of an example. But remember, regular numbers, we already know all those math rules. You've been learning them for years. So we're going to multiply or divide or add or whatever them first. Radical numbers, however, we can still do the same types of rules, but we have to only keep them inside of a radical, and they can only go with other radicals. So the square root of 2a times the square root of 9a cubed. Now, another thing you're going to find out with radicals is there's lots of different ways to do a problem. This one, you could go ahead and multiply them right now, or you could simplify that 9 and pull it out as a 3 because the square root of 9 is 3. But in general, I'm going to say it's usually better just to go ahead and multiply and simplify at the end. We'll just kind of have to play it problem by problem. So 2 times 9 is 18. There are no regular numbers in this case, and so we don't have to mess with that. We just multiply 2 times 9 is 18. A times a to the third, if you need the hidden one there, don't forget about it. You get 18a to the fourth. Now, we've got to pull out perfect squares. Well, 18 has a 9 in it. 9 times 2 is 18. And then a to the fourth is also a perfect square. So we end up with the square root of 9 is 3. And the square root of a to the fourth is a squared. Notice that I'm crossing them out when I pull them out, and I'm left with a radical 2. That is a fully simplified problem right there. All right, so that leads us to dealing with division. And division is where these problems can be at least more difficult because there's some involved steps. Let me erase this. All right. So let's start off with a fairly simple example of the square root of 36 over 49. Now, notice that we have a fraction inside of a radical. It's not really allowed, but it's easily gotten away from because anytime you have a fraction in a radical, you can just split it into a radical on the top and a radical on the bottom. So this becomes a pretty easy problem because the square root of 36 is 6. The square root of 49 is 7. 6/7 is the square root of 36/49. Okay? So not too bad, but it's when you're simplifying those that these become a little bit more difficult. Let me find an example of a problem. Because you're not ever allowed to have a radical number or a square root. We're not going to deal with anything like cube roots. You're not allowed to have a radical in the denominator. Okay, and so that leads me to 3 rules. Here are the 3 rules. Number 1, and this is something that I would add to your notes as a star. 3 rules when simplifying radicals. Number 1, no square roots can be inside of a radical. We have to simplify them. Number 2, no fractions can be inside of a radical. And then number 3, no radicals in a denominator. That last one is the hard part. Let me show you what I mean. The square root of 3 over the square root of 7. All right. So going by those 3 rules, do we have any perfect squares inside of a radical? The answer is no. 3 and 7 don't have any multiples that are square roots. The 2 smallest square roots are 4 and 9, and they're not factors of 3 or 7. Okay? Well, second one, no fractions in a radical. We've got a fraction here, but there's no fraction inside of a radical. So that's not a problem. It's the third part that's the problem. I can't have any radicals in the denominator. So how do I get rid of it? Well, if you'll remember, the opposite of a square root is something squared. So if I could square the square root of 7, that square root sign is going to disappear. But in math, I can't just randomly multiply a denominator by the square root of 7. Instead, this is called rationalizing. I multiply by 1. Notice that anything divided by itself is 1. The square root of 7 divided by the square root of 7 is 1. So I'm allowed to do it in math. But what it does is it changes where the radical sign is. Now on top, I've got 3 times 7 is 21. But on the bottom, the square root of 7 times the square root of 7 is just 7. How do I know that? Well, 7 times 7 is 49. And what's the square root of 49? 7. So I don't even have to go to this step of the square root of 49. Whenever you multiply a square root by itself, it's basically squaring a square root, and you're left with just the number inside. Now, are there any perfect squares in the square root of 21 up here? The answer is no. Some of you are going to be tempted to try to divide 21 by 7 and simplify it that way. But 21 is not a regular number. It has nothing to do with regular numbers. It's a radical number. So we keep radicals separate and regulars separate. Believe it or not, this is a fully simplified problem right there. Don't go any further. Let me erase and give another example. While I'm doing this, I'll also check and see how we're doing on time. I get 15 minutes for each of, and we're at about 9.5, so doing pretty good. All right, so let's try this one. Let's try the square root of 5 over the square root of 18m. Now, again, there's a lot of different ways to go about these problems. One way is to simplify at the beginning. I can't do anything with the square root of 5. But on the bottom, doesn't 18 have a 9 in it? that's really the square root of 9 times 2m. Okay, remember why we're finding that 9, that's a multiple of 18. It's because the square root of 9 is 3. So I can cross out the 9, and I've got radical 5 over 3 radical 2m. All right, so I've gotten rid of all perfect squares in a radical, but I still have a radical in the denominator, and that's a problem. I'm not allowed to have that radical down in the bottom. So what I do is I rationalize. Remember, rationalizing is multiplying by whatever the radical is, in this case 2m, over itself. I'm allowed to do this because I'm really just multiplying by 1. Well, what's radical 5 times radical 2m up top? That's a radical 10m over, well, I've got 3 things to multiply here. Here's 1, 2, and 3. But let's multiply these 2 first. What's the square root of 2m times the square root of 2m? It's a regular 2m. It's the whole reason we're doing this. And we still have that 3 on the bottom too. Okay? So we end up with the square root of 10m over a regular 6m. And that is a fully simplified problem because there's no more perfect squares in the square root of 10 or of 6. This 6 on the bottom is regular. It's fully simplified. All right, let me erase this. And I'll try to squeeze in one more example if we've got time here. Taking forever to erase. Come on here. Okay, let's check time. We're at 12 minutes, so maybe one more example. The square root of 7x over 3. Okay, 3 rules. Number 1, I can't have a fraction in a radical. That one's really not a big deal to take care of because I can just split it up into the square root of 7x over the square root of 3. Okay, but then I violate the 3rd rule. I'm not allowed to have a radical in the denominator. How do I fix that? I rationalize it, means making an irrational number rational, by multiplying by the square root of 3 over itself. And so I end up with the square root of 21x over 3. Now remember, that's a radical 21 and a regular 3. They don't have anything in common. I have to stop right there. So there's a pretty good example of the types of problems that you'll have. There's going to be some people who need tutoring on this one, and that's okay. This is the way you learn, is by lots of examples on this. I gave you a little bit bigger than normal assignment on Math Excel, but also some extra time until Thursday at 4. So hopefully this will help you. I also left a copy of my my PowerPoint presentation on LMS that you can go through if you want some extra look at things. But don't be afraid to come in for tutoring if you need a little bit of help virtually. All right, that's the end of it. See you tomorrow or Wednesday as we meet for class.